Let's take a look at Leet code question 20, valid parentheses. And this is a great question to solve if you're just getting introduced to stacks, because we make use of a stack to be able to solve this question. So, given a string S containing just the characters left parentheses, right parentheses, left curly brace, right curly brace, left square bracket, right square bracket, determine if the input string is valid. An input string is valid if the open brackets must be closed by the same type of brackets, open brackets must be closed in the correct order, and every closed bracket has a corresponding open bracket of the same type. And then we have some examples here. So the first example, you have a left parentheses, which gets closed by the corresponding right parentheses. The second example, you have the same thing, but then you also have a left square bracket closed by a right square bracket and a left curly bracket closed by a right curly bracket. And a third example, you see something that doesn't work or which returns false because you have a left parentheses and then a right square bracket, and then that doesn't close properly. So you get a false there. Go ahead and jump into the solution for this. Now, the first thing to note is if the string doesn't have at least 2 characters, it's not possible for it to have a closing or bracket. So it can't be valid. So if the length of the string is less than 2, we return false because the string doesn't have a valid closing brackets. And then I might just have a variable here just to keep track of my opening brackets. So I have this variable here called opening brackets, which will just be an array of all of the left brackets. So the left parentheses, the left square bracket, and also the left curly bracket. And the first thing we want to do is we can just have a check here, and we can say that if the opening brackets includes whatever the last character is, because we know that the last character always has to be a closing bracket. And if the last character is not a closing bracket, what we can do is we can simply return false because there's no way to close the bracket. And then I'm going to have a stack here. So I'm just going to let this, and this is going to be using an array because I'm not going to implement a stack just to solve this question. But we're just assuming that we only need to either push or pop, which are all one operations. We don't need any of the other array methods. So what we can say is, well, we can have a for loop, and we'll need to keep track of the index. So let's just use one of these old-fashioned for loops here, where I is less than the length of the string, and then we increment I by 1 each iteration. Basically, we want to check whether our opening brackets includes the particular character that we're looking for, or the character that we're on. So if the character that we're looping through, that we're on, is in the opening brackets, we can use our stack and we can push that to the stack. So our stack is just keeping track of the opening brackets. So if and then we don't really need to do anything more after that. So I'm going to continue here, but we could get the case that, it's not the opening brackets. So what we want to do in that case is we want to work out the top character, which we can determine from our stack by looking at the stack length -1, which is just the last element in the array. And essentially we can just do this check here, and we can say, well, if the element that we're on is equal to a end parentheses and the top character is equal to a left parentheses, or, and I'm going to copy this down, or this is a right square bracket and the top character is a left square bracket, or this is a right curly brace and the top character is a left curly brace. If that's the case, what we want to do is we want to pop from our stack. But if that isn't the case, we want to return false. And let's just shorten this up a little bit so it all fits on one page here. We can get rid of this or check here. And then what we want to do is we just want to simply return if the stack doesn't have a length. Okay, so let's go through this again. We'll just recap what we've done here. We know that if the string is less than 2 characters, you can't possibly have an opening and a closing bracket. So the string isn't valid. Then we want to detect if the last element or the last character in the string, if that's an opening bracket, then it's not valid because there's no way to close it because that's the last character. Then what we want to do is we want to have this stack here, and the stack is going to keep track of all of our left or opening brackets. So we're going to loop through each character of our string, and if the character that we're on is an opening bracket, we push it to the stack. So that means if we're looping through our string characters and the character we're on is not a opening bracket, it must be a closing bracket. So that means what we need to do is we need to, in order for it to be valid, the closing bracket must correspond to the last opening bracket or the top character. And we got this stack structure here. It's not a real stack, it's just an array, but we're using it in place of a stack because it's going to act as a stack, so we only care about pushing and popping. And that top character, we got this sort of, basically if the top character is a left parentheses, the character you're on must be a right parentheses in order for it to be valid. And that's true with the square and curly brackets as well. So let me get rid of this one here. And if that's true, we can pop the corresponding bracket from the stack. So we know that that bracket's closed. And then if we go to the next brackets, let's say the next iteration, and if that corresponds to the closing if this isn't the case and the corresponding closing bracket isn't related to the top character's opening bracket, that means we don't have a valid string, so we return false. And if it makes it through all of those, basically we just want to check if there's anything in the stack. Because if there's nothing in the stack, or the stack has no length, that means we've closed every bracket, and then that means this will be valid. So let's just take a quick look at the time and space complexity. So the time complexity, well, we have this for loop here. So we're doing a O of n memory lookup. And then within that, we've got this opening brackets includes. So the thing about this is opening brackets includes is a O of n operation, but we only have 3 brackets here. So you might want to bring this point up, because if you see a for loop and includes, that would technically be O of n squared. However, that's considering when the input becomes large. But here we know that there's only 3, so it's quite small, and you could argue that it's insignificant. So you could argue for O of n complexity, so that's something you just want to mention. And basically the space complexity is going to be O of n, because you're going to need to push through. Now it's possible that could be half of n, but that will just round to O of n. So that's the is valid algorithm question. Thanks so much for watching. Please subscribe to my channel, and I'll see you in the next video. Oh, and let me just submit this first. And we see that beats 20%.